Hi everyone, my name is Sabina Bruce and I'm a systems engineer focused on the MCU portfolio here at NXP. Welcome to this tutorial of the LPC5500 MCU series based on the ARM Cortex-M33. This video is going to focus on the dual-core feature of this series. The LPC5500 MCU series is based on a dual-core Cortex-M33 implementation that nearly doubles in performance. The primary CPU is intended for data-intensive tasks and provides features like ARM's trust zone technology, floating point unit, and memory protection unit. The secondary CPU only enables the NVIC and is intended to be used only within the system level. This CPU can be powered down when low power is required. The LPC5500 MCU series is an asymmetric architecture. This means that one core can run as a master and the other as a slave. In order for the slave to work or to wake up, it needs to be released. Its clock can be enabled through a register by the master core. It's important to say that the dual-core feature is available only in some MCU families in the LPC5500 series. Please refer to the datasheets for more specific information. When using the dual-core running mode, both cores need to communicate with one another. The LPC5500 series provides a simple means for this communication to happen. It's called inter-CPU mailbox mechanism. We're going to run the mailbox example code from the LPC55S69 SDK. We're using SDK 2.5. We are running this demo on the LPC Expresso 55S69 development board using MCU Expresso 10.3.1. We have already installed the LPC55S6X SDK from the MCU Expresso webpage. Now we're going to import the mailbox mutex examples. In this project, the core 0 sends the address of shared variable to core 1 by mailbox. We need to import the corresponding project for each Cortex-M33 core. In each project, we're going to set this flag equal to 1. In order to receive the data in the UART console instead of the semi-host console. Both cores are trying to get the mutex. After that, each core updates the shared variable and releases the mutex. If we check the main function within the core 0 source code, we can see that the core 0 initializes the mutex and the shared variable. After that, it will take the mutex and release it after printing in the UART console. Then it will wait for the core 1 to release the mutex. This variable right here is shared for both cores and is incremented by them. If we go to the main function in the core 1 source code, we can see that it is a pretty similar implementation. The core 1 is waiting for the core 0 to initialize and release the mutex. We need to build both projects. Each one will have its own debug session. It is important that we start core 0 debug session first, since core 0 needs to enable the slave core. We need to have a serial terminal to see the debug messages sent by the cores. In our case, we're using Teraterm. Next, we'll click the Run button. A quick note, be sure to click the icons on the right-hand side as this controls both debug sessions. Once we're in the debug mode, we can set a breakpoint in the while loop of core 0 and check that only the core 1 is printing in the terminal. Also, we can do this the other way around by disabling the breakpoint, resuming the session, and setting a breakpoint in core 1. As we can see, core 0 is the only one sending messages. The share variable has now been updated by both cores. This is a simple example of the LPC55S69 SDK to demonstrate the dual core usage with mailbox and mutex features. For more information, please visit the dual core communication application note.